In this problem, like the other parts to number 25, we want to calculate the H3O plus, the hydroxide, both of these concentrations, and the pH for this particular solution. And we're given 0.855% nitric acid by mass, and we're given some information about the density. In this problem, we recognize, okay, HNO3 is a strong acid, so the H3O plus concentration is equal to the concentration of this. We don't have the concentration of this nitric acid. We have percent concentration. So what we first want to do is manipulate this percent into a molarity. So let's take a look at the steps. First, what you want to do is take care of the percent. So 0.855% HNO3 is the same thing as saying we have 0.855 grams of HNO3 per 100 grams of solution. Okay, so the percent basically means you divide by 100. So now we have some grams to deal with, grams to moles, grams to milliliters to liters. We could handle that. So what we want to do here is convert the grams of nitric acid to moles. Using the periodic table on the front inside cover of your textbook, we have 1 mole of nitric acid coming out to a calculated value of 63.018. Okay, and what I get for the moles of nitric acid is 0.01357. I'm keeping an extra significant figure here to avoid rounding errors. So we got moles. Now remember, concentration is moles per liter, and we have grams of solution. So we're going to use the grams of solution and the density to find milliliters of solution. So let's take a look how that works. 100 grams we're basically going to divide by the density. So 1 milliliter of solution weighs 1.01 grams. Okay, so the grams cancel, and we're left with milliliters here. The value I get is 99.01 milliliters. Okay, we go ahead and convert this to liters. All right, milliliters cancels, and we're left with a value of 0.09901 liters. Okay, so now I have moles and I have liters. So we can go ahead and calculate the molarity of the nitric acid, 0.01357 moles of our nitric acid divided by 0.09901 liters is equal to 0.137 molarity HNO3. Okay, so that involved some work. We converted the percent to a grams per 100 grams of solution. We converted grams of the nitric acid to moles. We converted the 100 grams of solution to liters of solution, and we calculated molarity. Now the problem is straightforward. It's just like parts A through C to go ahead and calculate the H3O plus concentration and the hydroxide concentration. Okay, since we're dealing with a strong acid, we know that the H3O plus concentration is equal to the starting concentration of the acid. So it's just 0.137. Okay, so that was relatively easy. The hydroxide concentration is calculated by using the Kw. Kw is H3O plus times the hydroxide. So if we solve for hydroxide, that's Kw over H3O plus. And if we plug this in, we get 1.0 times 10 to the minus 14 divided by 0.137. And that's going to give us a final value of 7.30 times 10 to the minus 14. Okay, 3 sig figs, 3 sig figs, 3 sig figs for all of our values here. Okay, density is 3 sig figs as well. Now to calculate the pH, we do the same thing as per the other problems. We use the pH equation. The pH is equal to minus log of the H3O plus concentration. Okay, so we're going to use this nice little value we've calculated earlier. So minus log of 0.137 is equal to minus, and when you punch this into your calculator, 0.137 log, you get a value of negative 0.863. So don't forget to watch out for your signs. So the final pH of this solution is 0.863. Okay, very complicated problem because we're given these percent by mass units to start with. If you're interested in the other parts, A through C, go ahead and check out my other videos. Thanks for watching.